Hello, good day. So this is Group 4 and we are going to present our Lab 8 fourth day. So here are our codes, and these are the codes for part 1 and this is for part 2. So let's start with the first one. So this application will compute the factorial value of the number entered by the user. For the variable, we use x as the non-negative integer number that the user will enter. When the user enters as a non-negative number, the sequence will now begin to compute the factorial value using the codes. Factorial times times and equals to x or then the value will be shown to the user screen. So let's try. So yeah, this is the execute of our code. So let's proceed to the conclusion. So we learned that these codes are applicable in any lessons in calculus as long as exponents were present. For example, if you have f of x is equals to 3 and you got the given of okay, 4. So we use the 4. Okay, we use the 4. The hard one would be good for this example. So why? Then yeah, example, you need to find the value of x. So it's gonna be plus x. So alright, we can use the execution list for the reference in solving such equations. So let's just substitute this. So this is going to be 4 cubed plus x. And in the list, we refer the number of 64. So that means 4 cubed is equal to 64. 4 cubed. 64. Alright. So in order to find the x value here, you just need to transpose this number here. So alright, we got the negative 64 and x. So that would be the value of x. So these codes were really usable in calculus. So yeah, that's for our analysis. So let us move on for the part 2. So alright, int main is our data type and our variables are numbers 1 to 20. Right, 1 to 20. And we put their labels as this, where below angle will show the variables which is 1 to 20, then below t sign will show the value of sign of the number within each column. Then below the t-cos will show the corresponding cosine value of the number within each column. And lastly, below tan will show the value tangent uh, value of its column. So what I mean here is this: when you run this, there are gonna be a list of their values. So for our conclusion in here, the lists of these digits in the executions were accurate and reliable because if you use a calculator and type in the angle in the degrees, the answer are the same on the list. So let's take this for example. So we got the tan x, right? So let me just substitute one of these values. So we take for example 17, right? So the answer is 0.30. Alright, it's accurate. So you can always prepare into these lists. So these lists are applicable in definite integral. So as an example, so let's give an example again. Right? So back to the paint. And we got the given of integral of 0 to 1 sine x dx. So alright, first off, we need to integrate the sign because that's the integrand right there in order for us to evaluate 0 to 1. Alright, so sine in the integral of sine x is equal to negative cosine. Alright, so this is the integral, right? So let's just do this one. So this is gonna be negative cosine x and from 0 to 1 we evaluate this. So this is going to be negative cosine. Right, so first substitute the 1 and minus, and parenthesis minus again cosine 0. So the x will be the value here. We'll substitute for the x. Is the substitution for, you can use these numbers to substitute for the x. So right, substituting all that numbers, right, is gonna be a bracket because there's a parenthesis inside. So this is the final answer in calculus, but if you want an accurate and all digit answers, you're gonna refer into this list. So alright, negative cosine, so this is gonna be plus. Positive cosine is cosine 0 is 1, right? Because as you can see here, it's 1 in the 0, and cosine 1, right? Cosine 1. So this is gonna be negative 0.9999. That's a lot. 9, right? 8. So if you subtract this, this will be calculator minus point. No. 1 minus 0.999. 998. So this is the final answer, an accurate and final answer for this integral. So what I mean for this, wait, yeah, right. What I mean for this is that if you integrate and you have this trigonometric, what you call this, identities or functions, you can refer to this execution list. So, all right. That is all for our presentation, and I hope you guys learn from this presentation. And thank you. Peace.